Hi, this is a video to show off the new stochastic height blending sampler node for the Unity shader graph. I might port this to other shader graphs and extend it in the future, but this is the basic workflow. The goal of this node is to get rid of tiling textures. So the first thing we're going to do is create a shader. Let me go ahead and get rid of these. I'm running in the lightweight render pipeline. But this will also work in the HD render pipeline. So I'm going to create a PBR graph here. And I'm going to call this Stochastic Sample. And let me just load this guy up. Dock it back here. So here we have our basic shader graph. And first, let's just set up a tiling texture. So first thing we're going to do is get our UV coordinates and scale them. So to do that, we can just multiply our UVs. I wish multiply didn't open with all that stuff. So we're going to multiply our UVs by a value. And we want to make that value something the user can adjust. So I'm going to make a vector 1 here. And I'm going to call it, you can do it with a vector 2 if you want to scale it non-linearly, but for this it'll be fine. Texture scale. And I like to change the reference names. There we go. And the default should probably be, I don't know, 5. So we get some tiling. And let's go ahead, pop this guy out. And multiply. So now we've scaled our UVs. Next thing we want to do is sample a texture. And so for that, create a Sampler2D. The UVs in, and I'm just going to select a texture here, it's shore sand. So we can see it's already tiled, and we can plug that right into our albedo. And let's go ahead and hook up a normal map as well. There we go. And create a node, texture 2D. And go ahead and we'll put this into here as well and select our texture here, which is our normal map. And we will plug that into the normal. And that's going to look a little screwed up because I haven't set the type normal map yet. So we'll go down here and set this to be normal. There we go. And let's go ahead and hook up the other maps. Sample2D. And again, grab my UV scale. Set my texture to be this smoothness and AO map I have here. And this guy, we can take the green channel for smoothness, and I have the AO in the alpha channel. And if you're going to pack maps together where you have 2 single channel textures like this, it's best to put one texture in the color channels and one texture in the alpha channel, because then they get compressed independently and it makes the quality better. It does take up a little more memory than if you stuff them in all into the RGBs. But just a little note there. So let's go ahead and make a material for this thing. And there we go. And put it on this giant plane here. I have scaled this plane up. It is a 50 by 50 plane. And oh, I forgot to save the shader. Save asset. So here we go. We have our textures. We get some nice specular. Got our normal maps all working. But as you zoom out, you can tell that this texture tiles pretty badly. If we were to zoom out even more effectively by scaling it up, we really start to see the pattern, right? So this technique will get rid of that completely. It's based off of Erik Heitz, I think his name is, paper that Unity originally released an implementation of their version, which used a different type of blending than mine does, and it required pre-processing the textures and having gradient lookups and all kinds of stuff. And so I came up with a version of it which is actually much simpler to implement. It's a little faster because it has less texture lookups and less stuff to do, and actually I think produces better quality in almost all cases. So we can talk about that in a minute, but let's go ahead and change our shader to do that. So this is basically just a tiling texture shader right now, nothing fancy, and we're going to actually make it so that you can't see the tiling at all. And so what we're going to do is we're going to get rid of these texture sample nodes we've created, and we're going to replace them with new ones. Delete. And let's go ahead and create a new node. We're going to go to Stochastic Sample2D. And this works just like the texture node, so we can go ahead and we can select our albedo map here. And we can plug in our UVs. And you'll notice we have some extra inputs here, which we'll get to in a second. We can just leave them blank for now. And let's go ahead and take our output of that and plug it into the albedo. And we can save this just to preview it. So we're just looking at albedo now, so it's going to look crappy, right? But we really need the normal in there to make it look good. So let's go ahead and do that. Let's create another one of these. Stochastic Sample2D. And this one we're going to assign our normal. And then we're going to come down here and change our type to be normal. And then let's go ahead and plug in our UVs there. There we go. This is the preview window. This guy. And we're going to take the output of that and put it into the normal. And then finally, let's create our last one. And we're going to grab those UVs again. Select our texture, which is this shore sand smoothness one. And let's plug the green channel into the smoothness and the A channel into the occlusion. I'm just going to arrange these a little bit so they're a little better. So there we go. Save the asset. And now we'll go over to our scene view. And you'll notice that we no longer have tiling. However, there's something we can do to improve the quality here. And that's where those extra parameters of the node come in. So what we're going to do is go back to our example and talk about those parameters. So we have a blend input, a contrast input, and a scale input. So by default, each of these nodes is doing its own blending and trying to, basically what it does is it samples the texture 3 times in using a noise pattern, and then it blends it together. And the trick is really in the blending. You'll notice that this also has a blend 3 output, and that's for chaining these together. The contrast controls effectively like how quickly it blends, and the scale controls the size of the sort of randomly generated patches it's going to use to pretend that you have these 3 layers in different arrangements that it's blending together. And you'll also notice there's a height channel setting here. And that actually can be set to red, green, blue, or alpha. And in this case, I have a height map packed into the alpha of this diffuse map. Or you can set it to luminosity. And what that will do is it'll take the luminosity value of the RGB channels. So you can use this. Any of these textures could be the one that sort of controls the blending. But if you have height maps, then that's probably the best way to do it. But any data will actually work. The luminosity will work as well. And so what that's going to do is determine how these things get blended together, like what data it's going to use to determine the blend. And it uses effectively a height map blend. So it can use the grayscale and luminosity from the image to do that. It can use one of the texture channels, which may or may not be height data. And so that gives you that flexibility. So it'll work with basically any texture. Now, once you've determined the blend, we want to use the same blend on all 3 textures. The reason is that will give it a really nice consistency, so the details really line up, so that the normal map doesn't decide to do a blend a little bit different. So to do that, we just chain one blend into the other. So you plug this blend into this blend, and then you come down here, and you can take it from the original, or you can take it from here. Doesn't really matter. They will chain together however you do it. And now what will happen is it'll use the height map to blend these 3 together, the 3 samples it takes, and then it'll use the same blend on all 3 textures, so they'll line up really nice. And finally, we have these other 2 parameters, which are the contrast and scale. So let me go ahead and make some exposed properties for those. We're going to do for one for stochastic contrast. And let's go ahead and change this too, so it's something a little nicer. And we're going to actually set this contrast to be a slider value. And the reason is because we don't really want it to go all the way to 0, and we don't want it to go all the way to 1. We want to kind of keep it somewhere in that range. And we actually want the default to be fairly small. I actually find like a 0.01 works pretty well, really tight contrast. I'll explain why in a moment. Well, we'll be able to see why. And then here, we're going to do the stochastic scale. And this is basically the size of the virtual triangles it's going to, sample from the texture. And I'll be able to show that in a minute too. Stochastic scale. And the default for that should definitely be 1. And I'm going to go ahead and set it to a slider as well, because I think there's kind of a decent range for this, and it's between 0.5 and 1.5. And I'll explain why that is in a moment. So let's go ahead and put these variables out in the shader graph here so we can use them. So we have our contrast, and we have our scale. And let's go ahead and plug them in. So contrast goes in the contrast, scale goes in the scale. Now the contrast will be ignored on the future ones, so you don't have to hook that up to the future ones because we're chaining that blend together and it's already used the contrast. So that's just a little note. I mean, you can hook them up if you want, it doesn't really matter. I tried to figure out how to get the shader graph to hide these nodes when they're chained, but I have not been successful at getting that to work yet. And so final scale goes in here. And there we go. There's our shader. Let's save it, and let's go over to the scene mode and show off those controls and make sure they're hooked up correctly. Okay, so you can see here that even when I tile this texture, let's tile it 10 times, you don't get any tiling whatsoever, right? You can't find a repeating pattern there, really. It sort of always looks unique. It always looks self-similar, but it always looks unique. That is very cool. Now let's look at those settings we added. So the contrast is basically controlling how quickly it blends between these virtual triangles. So when you have a really low contrast, you're going to get, a high value in contrast, you get this big blurry wash, right, where it tends to blend between it much softer. And as you tighten that contrast up, you're going to get sharper and crisper details. And this is why I like it kind of as high as it'll go, almost a really high contrast, low value. I think it retains more of the original texture, and it doesn't wash it out as much. And then finally the scale. So the way this is working, and you kind of see this with the scale, so as I change the scale, you'll see these things sort of warp around, right? And what it's actually doing is the 3 texture samples are pretending that there are 3 randomly placed triangles on the texture. And it chooses 3 of these virtual triangles on this sort of virtual grid, and then basically samples from the 3 of them and blends them together, right? And that's what gives you your randomness. And what the scale does is scale up the size of those triangles. So when you get really small, you have smaller triangles, which means you're blending more often, which means you're getting smaller little chunks of the texture. And when you make it really large, you're going to get triangles that are potentially the size slightly larger than the texture. So if you go large enough, if you really put this up to 10 or something, you'd start to see tiling texture, right, in areas. And the reason I expose this value is I find personally that I like it so that you get the full texture sometimes. So I actually like it a little bit over 1. So that sometimes you get like a nice big solid chunk of your texture, which helps retain the original intent of the texture. Because compared to the original texture, this one has a few more bumps on it, right? Because since we're blending these bumps together and we're using height map based blend, the higher bumps tend to win out. So let's talk about performance. The performance of this shader is that it triples your sample count for the textures that are sampling with it. So in this case, we are sampling 3 textures, and we are sampling them 3 times each, so we're doing 9 samples. Now that doesn't mean that it's a 3x on performance cost, because the way GPUs work is they tend to cache things that you've just accessed. And so a lot of that texture is still going to be, you know, in local memory, and so repeated texture fetches to the same texture will speed it up a little bit from the cache. So yeah, so what else could we try? We could play with changing the shader to use the luminosity, just to show you an example where you don't have a height map, and see how that comes out. Now this texture, you know, you can tell it's a pretty bland texture, so using luminosity is not going to be marvelous on this, but it'll still work. We go over here to our scene view, and you can see even just using the luminosity of the texture, not using a height map, we're still getting a really nice result, right? We're still getting something that doesn't tile, that has the sort of overall look of the original texture, and yeah, and we don't have to worry about it tiling, which is awesome. And I'm just going to go switch that back from luminosity back to the A channel where I have my my height map. So this was originally featured in MicroSplat, my terrain shader, which you should definitely check out if you need terrain shaders. But I figured I could take this technique and put it into the shader graph so that it could be used in more places and on more things that you wouldn't want to texture with a terrain shader. Yeah, oh, so let's compare this to the original paper, okay? So the original paper, the idea of the original paper was, the first part I really liked. You take these 3 virtual triangles that you randomly sort of orientate on your texture, place on your texture, you sample from them, and you blend that together, right? What I didn't like about the original technique was how it blended that data. So if you read the original paper, what it tries to do is preserve the histogram of the image, okay, which is basically like preserve the overall colors and, you know, stuff of the image. And what I found that really did was it washed out everything, kind of like when I had the blend factor really wide, but worse. And so instead of getting something that had these real high and lows and these like distinct chunks of texture like we have here, I was getting something that was kind of a big smear of them. And then on the back end, it actually added a ton of complexity because the textures had to be processed into a different format, which took minutes for any, you know, just for these 3 textures would probably have been 30, 40 seconds. And so if you're doing hundreds of textures, then you have to process a lot of them. And you couldn't use those textures in the normal way anymore because they're now in this weird custom format. So that wasn't great. This, you don't have to do any of that. You can just use your regular textures. And additionally, not only can you use your regular textures in your regular ways, but use them in this as well, which is great. You don't have to produce extra textures. So the original technique produced these little gradient textures. So now you would have these 3 textures and these 3 little gradient textures as well that it used to help preserve its histogram. So, so overall, I really liked some of the ideas in the original paper. And thought that they did a really good job with it, but I felt like the blending operator was far more complex than it needed to be, and using a height blend operator, you could get a much better result that you know, produces the intent of the paper. And if you don't have height information around, that's fine too. You can use the luminosity of an image, or you could use one of the normal map channels, right? whatever you want to use, it'll probably produce a good result. So yeah, hope that explains everything. Let me just look at the nodes and make sure there's nothing I've missed. So the other stuff that's on this node is exactly the same as the regular sample stuff. So you have your outputs for your RGBA channels and your RGBA output. The only new thing on the outputs is really this blend 3, so you can chain things together. And then your texture input, same as normal. And then you have your UVs, your sampler states, if you're doing stuff with sampler states to save samplers. That's all the same as on the standard node. So really what this adds is the input for the blend, if you're chaining the blends together, your contrast and scale settings, and then this height channel property here so that you can select what channel you expect to blend based on. All right, maybe I should name it something other than height channel, but I do think the height map is probably the best thing that you can blend on if you have them. Obviously the contrast doesn't do anything if you're providing the blend weights, as I've talked about, and you know, the tangent space here is not going to affect anything if you're not a normal map. But that's all part of the regular sampling node. So I think that's basically it. The package just includes the new node, this example that we've just built, and these couple textures. And once you install it, it'll show up in your shader editor, and you can make surfaces not visibly tile, which is very cool. All right, thanks.